Hey there, Jim Gavigan, Industrial Insight. It's been a while since you've seen me talk on one of these kind of informal videos. But I was just sitting here working on something for a customer, and Paul Sciaramato from Pattern Discovery and I are going to talk. Matter of fact, we had a conversation this morning talking about data quality and data fidelity, and we're getting ready to shoot a video next week about that you'll be seeing in the coming weeks and month or so leading up to Pi World in March. But I'm going to give you an example of why data quality and data fidelity is so important, and how most of our industrial companies that we do business with sometimes have no, or actually most of the time, have no idea what their data quality really looks like. So we're doing a conversion from another historian, this happens to be IP21, to Pi. Customer made that decision. So we're getting all the old data out of IP21. And I had this file over here that was a 500 meg file for 1 month worth of data. 1 month. And all we're getting is tag name, timestamp, and the value. That's it. 500 meg, half a gig. I'm like, what in the world? And I'm looking at the tag name. It's a 2-hour moving average. And you have half a gig of data. So I went to look at it, and I popped this file open, and it looks like around half a second. So 4/10, so we got 4/10 of a gap, 7/10, 7/10. 4/10. So around a half a second, they're trying to recalculate this moving average, 2-hour moving average. So I'm sitting here looking like we're a minute in and the value has not changed. Oh, it did change. It went down, a whole 1/100th of a point. 2-hour moving average, half a second scan rate. And here's the thing, the value you're getting, and here the other thing about it is their interface was scanning their data out of their DCS every 5 seconds. But someone configured the tag to read every half a second or to calculate every half a second. So basically the data fidelity coming in was 5 seconds, and at 10 times that rate, they're doing a moving average calculation for the last 2 hours. And you think about it, my suspicion is this number probably doesn't move a whole lot. So you think about this is getting recalculated out every half a second, taking 2 hours worth of half-second data that's getting scanned every 5 seconds. Are you catching the ridiculousness of this? And we see this all the time. We either see this where some engineer says, give me all the data as fast as you can give it to me, without truly understanding what they're looking for. Or we see the opposite, and they are getting almost no data because the IT guy got mad 20 years ago or 10 years ago and, killed the fidelity because he's like, you're filling up my hard drives, and I can't keep, adding more space or putting in new hard drives in these machines. So it's kind of this either set and forget mentality, or it's the engineer said, go get me everything. And this becomes a problem. Like, we're trying to do this conversion, and literally we don't have the time to go get all the raw data out of the system to put into Pi, because we wouldn't get all the data pulled out in time. We've got this thing basically running 24 hours a day, 7 days a week, until their license file runs out with Aspen. And so what we've had to do is make, a few compromises to make sure that we get enough data where we can reasonably reproduce what was going on in their plant going back 7 years for about 4,500 tags. We could have chosen some other methods, but for this kind of size, I mean, this seemed to work probably about as well as we could have expected. I think especially knowing what we know now about some of the fidelity and data quality issues we have, but we see this all the time, and this is why Paul and I are going to talk and shoot a video. I wanted to kind of prime everybody. I mean, this is kind of ridiculous. So, and what's nice is, we've been talking with the engineer about some of these issues, and he said, yeah, That was before I got here, and before, I kind of explained to people, this is what you're doing, because a lot of times people don't really understand. And so I'm trying to make sure that I continue to raise this awareness. And you have to really be careful, when you say, I want to store all the data, because you want to start doing advanced analytics. What if I was storing data like this and I said, hey, I want 5 years and I want a 15-minute average? Well, you've got, let's see, basically 120 values per minute times 15 minutes. So you've got to do all that math. Every time you want to get one 15-minute average. And, let's say you've got 100 tags you want to pull to hand to your data scientist. It's going to take you forever to go get that. And most people don't think through, like, what is this going to do to impact? Or you try to just pull up a trend. Because whatever tool you're using, whether it's Wonderware, IP21, Pi, Ignition, whatever historian, whatever you're using to log the data historically, and you pull up in their trending tool, it's going to pull all that data. So imagine I want to go get a month's worth of data of this 2-hour moving average. A month worth of half-second data, that's going to take forever to pull. So you really have to kind of think about, when you start collecting data, and you got to really think about, how fast do I need it? How much of it do I really need to store, and what's useful? And, whether that's compression or there's, you have some other method, to handle it, you have to handle that, because you can't store every data point. This is what happens to you. So, and some of the 5-second data that are uncompressed, we're seeing, like 150 meg files for 1 month. And literally those, like, we'll do a query of 10 tags for 7 years, and literally it'll take 2 days to go get that data. 2 days to go get it. At pretty decent throughput. So I just think, it's a really important topic. Most people ignore it. And I really think everyone needs to think about that when they're storing data. So hopefully this helps. Hopefully this gets you thinking. And hopefully it primes what Paul and I are going to talk about in the coming weeks.